Hello everyone, myself Shruangi Desai, your instructor for the video series of data mining and business intelligence. Today's our topic is FP growth algorithm. So let's get started. In previous video, we understand the concept of a priori algorithm, which is used to find out the frequent item set. But it tends to create multiple candidate item set, which requires ample amount of time and space, so that the efficiency of a priori algorithm is reduced. As an alternative, we have another algorithm that is called FP growth algorithm, which is used to find out the frequent item set without creation of candidate item set. It is a two-step approach. In step 1, it builds a data structure called the FP tree using two passes over the data set. Whereas in step 2, it extracts frequent item set directly from the FP tree. So let's understand this concept using an example. Here we have a table that represents transactional data. In our example, we have 10 different transactions associated with the items. Now, step 1 is to find out the support count of each of the unique items from all the 10 transactions. So, this table contains all the filtered out items that satisfy the requirement of minimum support count and all the items that does not satisfy the requirement of minimum support count is ignored. That is item O, I, J, L, P, M and N. In our example, the minimum support count is 2 and all these items has a support count of 1 only. That is less than the requirement of minimum support count, and that is why these items are eliminated from further processing. So let's start with the step 2. In step 2, we have to reorganize the items in all the transactions according to the frequencies, and also we are going to ignore all the infrequent items from all the transactions. So let's understand with transaction 1. In transaction 1, we have 6 different items, that is A, B, C, E, F and O, out of which item O is infrequent, and that is why we have removed it from that transaction. Also, the remaining items, that is A, B, C, E and F, is rearranged according to their frequencies. Same will be applied for transaction 2, in which we have 3 items, that is A, C and G. It is already sorted according to the frequency so that we don't have to do anything. Now transaction 3, in which we have 2 items E and I, out of which I is infrequent, so we have just removed it from the further processing. And same is applied for remaining transaction, that is 4, 5, 6, 7, 8, 9 and 10. We have removed all the infrequent items from all those transactions, as well as remaining items is sorted according to their frequencies. Now let's start building the FP tree. For that we require the modified transaction set as well as a header table which contains the link to all the nodes in the FP tree. Now start creating the tree. We first create the root node, that is a null node. Now we have to add all those nodes that is in transaction 1. In transaction 1 we have 5 different items, that is A, C, E, B and F. Initially in our FP growth tree we have no such nodes. So we will start creating nodes for all these items in exactly same order with the count of 1. So we first add node A with count of 1, then we will add node C and link it with the node A and also initialize it with count 1. Now we will add node E and link it with the node C and apply the count 1. Same goes for node B and node F. Also, we have to link all these nodes with the header table. This is how our tree looks like after the first transaction. Now let's move forward to the second transaction. Here we have 3 different items, that is A, C and G. Starting from the null node, we need to check, do we have a direct link for node A from null? So yes, we do have a direct link of node A to null. So that's why we just increment the count of that node. Now check for C. Do we have a direct link of node C to node A? So yes, we have a direct link of node C to node A, and that is why we just increment the count of that particular node. Now check for the G. we do not have such node in our FP tree. So here we need to create a new node with labeled as G and count 1, and we link it with node C. Also, this is the very first time that node G is included in our tree, so we have to give it the link with the header table as well. So this is how our tree looks like after second transaction. Now move forward to the third transaction. Check from the null node. Do we have a direct link to node E from null? No, we do not have a direct link of node E to null, and that is why we need to create a new node that has a direct link with the root node, and also initialize it with 1 because it is very first time traversed. We also have to link this node with the previous node that is already there in the tree. That is, we already have a node E in our tree, so we will link this node with the previously created node. Now, this is how our tree looks like after the third transaction. So let's move forward to the next transaction. Check from the null node. Do we have a direct link to node A? Yes, we do have a direct link to node A to null, and that is why we just increment the count. Now check for node C. We have a direct link to C to A, and that is why we increment the count of node C. Now check for node E. We have a direct link to E to C, and that's why we just increment the count of node E. Now check for G. Do we have a direct link from node G to node E? No. In this case, we have a node G which is linked with node C, but not linked with node E, and that is why we need to create a new node which is linked directly with node E and initialize it with the count of 1. And same, we have to create node D which is linked with directly with node G and initialize it with count 1. Here we already have a node G in our tree, and that is why we just have to link our newly created node with the previously created G node. Node D is created for very first time in our tree, and that is why we have to link it with the header table. So that is how our tree looks like after the fourth transaction. Now let's move forward to the fifth transaction. In this we have 4 different items, that is A, C, E and G. Starting from the root node, check for the direct link to node A. Yes, we have a direct link to node A, and that's why we just increment the count of node A. Now check for the node C. We have a direct link from A to C, and that's why we just increment the count of node C. Same goes for node E. We have a directly linked node E to C, and that's why we just increment the count of node E. Now check for G. We have a node G which is directly linked with node E, and that's why we just increment the count of node G. So this is how our tree looks like after the fifth transaction. So let's move forward to the sixth transaction. In sixth transaction, we have only one node, that is node E. Start from null node. Do we have a directly connected node E? Yes, we have a directly connected node E, and that's why we just increment the count of that node. So this is how our tree looks like after the sixth transaction. So let's move forward to the next transaction. In here, we have 5 items, that is A, C, E, B and F. Start checking from the root node, that is null node. Check for the directly connected node A. We have a link to node A, and that's why we just increment the count of node A. Now check for the directly connected node C. So we have a directly connected node C to node A, and that's why we just increment the count of node C. Now check for directly connected node E. We do have such node, so we just increment the count of directly connected node E. Now check for B. We have a connected node B to E, and that's why we just increment the count of node B. Now check for directly connected node F. So we have a directly connected node of F to B, and that's why we just increment the count of node F. So this is how our tree looks like after the 7th transaction. Now let's move forward to the next transaction, which contains item A, C and D. Start checking from the root node, that is null. Do we have a directly connected node A? Yes, we do have directly connected node A, and that is why we just increment the count of node A. Now check for directly connected node C to A. We have such node, so we just increment the count of node C. Now check for directly connected node D to C. We do not have a direct connection between node C and node D, and that is why we need to create a new node that is directly linked with C and label it with D and initialize it with count 1. Now we already have a node D in our tree, and that's why we have to link newly connected node D with the existing D. So this is how our tree looks like after the 8th transaction. Now let's move forward to the next transaction, which has item A, C, E and G. So start from the root node, that is null. We have a directly connected node A, so we just increment the count of node A. Then check for node C. We have a directly connected node C to A, so that's why we just increment the count of node C. Now check for node E. We have a directly connected node E to C, and that's why we just increment the count of node E. And check for node G, which is directly connected to node E. So we have such node, so we increment the count of node G. And this is how our tree looks like after the 9th transaction. So let's check for the last transaction. It has the same items as the previous transaction, that is A, C, E and G. So start from the null node. We have item A connected directly with the null node, so we just incremented the count of node A. Then check for node C. We have directly connected node C, so we have incremented the count of node C. Check for node E. We have a directly connected node E to C, so we just incremented the count of node E. And last is G. We have a directly connected link from node G to node E, and that's why we just incremented the count of node G. So this is how our tree looks like after the 10th transaction. Now the final stage is to find out the frequent item set from this FP growth tree. Now let's discuss the advantage and disadvantage of FP growth algorithm. FP growth algorithm is much more faster than the a priori algorithm, as it does not need to create any candidate item set, and it only requires 2 passes over the dataset. However, it also has a set of disadvantages. FP tree may not fit in the memory, and FP tree is expensive to build. That's it for this lecture. Thank you.